Hello! In this video, we are going to prove the following theorem. Suppose a and b are real numbers. Then negative a is greater than negative b if and only if a is less than b. Now in this series, we are using a list of 10 axioms for the real number system, and I'll leave that list of axioms in the description below. Now in this video, we are going to be using the following axioms. Axiom 1 and 2 are just the commutative and associative laws. Axiom 4 tells us that there exists a real number, which we call 0, that has the property that x plus 0 is equal to x for all real numbers x. And Axiom 5 tells us, for all real numbers x, there exists a real number, which we call the negative of x, that has the property that x plus the negative x is equal to 0. Now also, our real number system is equipped with a subset called the set of positive real numbers, and it's denoted as R+. Now, using the set of positive real numbers, our definitions of greater than and less than are as follows. Suppose a and b are real numbers. We say a is greater than b if a minus b is a positive real number. We say a is less than b if b is greater than a. Now, a fact that we have proven, which uses the greater than relation, is the following. Suppose a, b, and c are real numbers. Then a is greater than b if and only if a plus c is greater than b plus c. Okay, so now let's get into proving this theorem. To start out the proof, let's first apply star. Applying star, we're going to take a to be negative a, b to be negative b, and c to be a plus b. Well, then we have negative a is greater than negative b if and only if negative a plus b is greater than negative b plus a plus b. And the idea is we can show that this simplifies down to b, this simplifies down to a. So this is equivalent to saying b is greater than a, and then by definition of less than, that is equivalent to saying a is less than b. Okay, so to show that this simplifies down to b and this simplifies down to a, we are going to be applying axioms 1, 2, 4, and 5. First, by axiom 2, we can move these parentheses around negative a plus a. And then by axiom 1, negative a plus a is equal to a plus negative a. And then by axiom 5, a plus the negative of a is equal to 0. But then by axiom 1, 0 plus b is equal to b plus 0. But then by axiom 4, b plus 0 is equal to b. So through this chain of equalities, we have established that negative a plus b is equal to b. Now let's establish that negative b plus b is equal to a. First, by axiom 1, a plus b is equal to b plus a. But then, the same argument that we did here shows that negative b plus a equals a. Because all we're doing is we replace a with b and replace b with a. So b is replaced with a, and we would get negative b plus a equals a. Right? The only difference is, to get this equals a, we do exactly what we did here. It's just that a and b are swapped. So we have established that this is equal to b and this is equal to a. Therefore, this inequality is equivalent to saying b is greater than a. And then, by definition of less than, to say that b is greater than a is equivalent to saying a is less than b. And now, putting this all together, we see that negative a is greater than negative b if and only if negative a plus b is greater than negative b plus a plus b, if and only if b is greater than a, if and only if a is less than b. So we have a chain of if and only ifs showing negative a is greater than negative b if and only if a is less than b. And that is exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.